So it turns out that there is another algebraic way to solve a system of equations. We saw that using the substitution technique at times can get a little crazy right at the very beginning when we start solving for x or y and introduce fractions, then we got to push fractions around. And so it turns out that there's another technique that can be a little faster, but there's a few more steps and some nuances that we have to get used to. But once you get used to them, it's really nice. This method is called the elimination. It's a nice method. I know most of you are going to love it, but unfortunately this method only works for a linear system. So make sure, even though this might end up being your preferred method, make sure you understand how to solve using substitution, because that method I showed first works all the time. For any system out there in the whole wide world, you can always substitute. But elimination works very nicely for lines. So before I get into the framework and the step-by-step process, let's just kind of take a look at this and kind of notice something. If we take a look at this guy right here, if I basically just start adding up things, right? X and x gives us 2x, and the plus y and the minus y, well, those actually are opposites, so they'll go away, and we're left with 2x equals 16. Do a quick division by 2, and lo and behold, we get our value of x equals to 8. Now, we've seen this system several times. We saw it at the very beginning when we were graphing. We just used it in substitution, and so we know that x equals 8 is actually the value. And look how fast that was, because we were able to eliminate the y. Now, why that occurred is because the coefficient, the number in front of the y, were opposites. Here it was plus 1, and down here it was negative 1, and so that's the condition I need to basically eliminate a variable. And so we performed that, and we were left with the variable to solve for, and it was very, very fast and very, very nice. So now that we've kind of seen that, let's go look at this idea here, and we'll come back to it and solve for x. So the first thing we have to do is decide which variable to eliminate. Well, that was easy for us because I can see that the coefficients are opposite, so we started by eliminating y. But let's rewrite this system. What if I wanted to eliminate the x? What would we have to do? So we're going to decide to eliminate x. So that's the first thing. Decide which variable to eliminate. Look at the coefficients. We need an opposite. So right now the coefficient, the number in front of this x is 1, right? And the number in front of this x is also 1. So unfortunately they are not opposites. So we're going to have to do something. So step 3, we're going to use our multiplication principle of equality to create the situation that I want. So what I'm going to do is basically take this second equation, and how about I multiply both sides by negative 1. What that's going to create is a new system. So the first equation, I didn't do anything to it, but the second equation, when I multiply everybody through by negative 1, I end up with that, right? Negative 1 times x is negative x, a negative times a negative is a positive y, and 6 times negative 1 is negative 6. And so you'll notice by doing that step there, we're ready for step 4, right? In our new system, we can combine like terms again. So step 4, when I do this, x take away x, well, they eliminate. Y plus y is 2y, and 10 plus a negative 6 is 4. And now what we can do is solve step 5 there. We can solve for the remaining variable. So I'll take both sides and divide it by 2, and we get y equals 2. So what's the ordered pair that solves this system? Well, it's the same ordered pair that we saw for graphing, that we saw for substitution, and now that we get for elimination. And so it's 8, 2. And again, the idea is we're going to decide which variable we want to eliminate. We're going to look closely at their coefficients, their number parts. We need them to be opposites. If they're opposites, we can go to work. If they're not opposites, we do a multiplication to create the situation. Once we have our new system, we combine like terms. Things should start to eliminate, solve for the remaining variable, and then basically redo the steps as you'll see in the next example. So there's the game plan. So next one. Again, we've already solved this system. We did it graphically, and we did it algebraically through substitution. So here's what the elimination technique would look like. First I have to figure out which variable I want to eliminate. So how about we eliminate x? And so when I eliminate x, I'm going to look at the coefficients, and I'm going to notice that the coefficient up here is 2 and it's 1 down there. They're not opposites. So I need to do some sort of a multiplication to create that situation. So how about, let me leave the first equation alone, and I'm going to take the second equation and I'm going to multiply both sides by -2. Let's see if that creates what I want. So the first equation stays the same. The second equation, when I distribute everything out, I get a -2x plus 8y, right, equals, that's going to be 16. And lo and behold, I have exactly what I want, right? So if I combine, we're basically at step 4 here. If I combine all my like terms, those are eliminated. 3y and 8y is 11y, and 15 and 16 is 31. We'll solve this by taking both sides and dividing by 11, and we get 31 over 11, which is what we found with the substitution technique. So that is pretty slick. Okay, so what about if we go back and I want to eliminate the y? Well, I noticed that eliminating the y, that one coefficient is 3 and the other one is -4. So we really have lots of problems. And so what do we do here? Well, the good news is they're already opposite sign. I just need these guys to be the same value. I need them to be opposites. So the way we're going to do this is, how about we take the top equation and we will multiply both sides by 4, and we'll take the bottom equation and I'll multiply both sides by 3. It's kind of like an LCD. Alrighty, and let's see what happens here. So if we do all the multiplication up here, we end up with 8x plus 12y equals, I believe that's 60. Let me make sure I got my. If we do the distribution here, we end up with 3x minus 12y equals -24. Here's my new system. So basically we'll combine like terms in the new system. When I do that, the y's go away just like I planned. 8x and 3x is 11x, and 60 take away 24. I believe that'll give us 36. Divide both sides by 11, and we get x equals 36 over 11, which again, I believe, was what we found earlier. And so our ordered pair that solves this is 36 over 11 and 31 over 11. And there is the elimination technique. The thing that takes a lot of practice is knowing, what do I multiply things by? Sometimes I don't need it because there's elimination already ready. Sometimes I only have to multiply one equation to get the job done, and then sometimes I'm going to have to multiply both of them to get the job done. The key is I need coefficients to be opposites, and we have the multiplication property of equality to help us out. Obviously we need more practice. We're going to see this in a couple more videos.